This is Milani, Chapter 15, Section 5, Problem number 1. In this problem, we are trying to find the area between two equations. It can be two curves, it can be one linear equation and one polynomial with the quadratic equation or anything. Now, in this problem, it says I need to find the area between the x's 1 and 2, and my equation inside the parentheses I made it more clear, which f of x is equal x to exponent 3 and g of x is equal 0. Now, even though we know 0 is x-axis, that's the equation of a line for the x-axis, but still, because it says between, then we have to use by 5 steps, which we already talked about it on previous PowerPoint. Step number 1, set both equations equal each other. That means f of x equal g of x. So they equal each other and solve for x. This is easy. I can get cube root of both sides, which x is equal 0. Now, the first thing we have to pay attention is 0 between 1 and 2? At this problem, no. 0 is not between 1 and 2, then I will ignore it. But in case, if it is between these two, we have to treat it different way, which we will talk about it on different PowerPoint. Now, that means 0, I ignored it. Then, step number 1, set both equations equal each other, solve for x. Step number 2, subtraction of an antiderivative. You don't have to graph it, but in this problem, I will graph it because I want you to see it better. But honestly, you don't need to graph it. Now, by looking at my graph, the curved graph is the f of x, and this graph is my g of x. That means between 1 to 2. I have just one piece graph between 1 and 2. Find out which equation is higher. Then, you can choose any number between 1 and 2, which I can choose 1.5. If I replace the x by 1.5, is going to be 1.5 to the exponent 3. If I replace the x in the g of x by 1.5, my y is going to be 0. In this one, I don't even need to calculate it. The answer here, x is 1.5, my y is 0. The answer on f of x, x is equal 1.5, my y definitely is going to be more than 0. That means my f of x is going to be higher than my g of x. Then, when we set step number 2, subtraction of an antiderivative, that means f of x first minus g of x. Now, my f of x is x to exponent 3. My g of x is going to be 0. Now, this problem, if the 0 is in the end, is no big deal. I can ignore it. That means right away, this one is the simple antiderivative. This is the same as 15.1. You can just get the antiderivative. Antiderivative of x to exponent 3 is x to exponent 4 over 4. But again, I like to show you a lot of steps. That's the reason Before I jump to the antiderivative in my PowerPoint, I show it to you, which minus 0 is gone. That means I have just this left, which antiderivative of this, few minutes ago we talked about it, which is going to be equal this. Now, this is my step number 2. Step number 3, replace the x by the higher x value. The higher x value is 2. Replace this x by 2. And then 2 to the exponent 4 is going to be 16. 16 divided by 4 is going to be 4. This is the result of step number 3. Step number 4. Replace the x by the lower x value, which is 1. Then right here, replace this x by 1, 1 to the exponent 4, and this denominator 4 carry it down. 1 to the exponent anything, it doesn't matter if it is the positive 1 or positive zillion. My answer is going to be 1 over 4. Then, step number 5. The higher x value result minus the lower x value result. For minus 1 over 4, if you want it, you can write it down the 4 as a common denominator with this 4, which is going to be 16 over 4. And then combine the like term, which your answer is going to be 15 over 4. And that is going to be the area between my f of x and g of x between 1 and 2.